Task 5. Enable BFD in the OSPF area 0 to speed up OSPF conversions. In the previous task, we configured IPFRR on PE2, so PE2 can have a main route to destination 10.0.5.5/32 and a backup route to same destination through backup next hop 10.0.0.10 and the backup interface Ethernet 101. So if the main route to network 10.0.5.5 is faulty, PE2 can switch to the backup next hop or the backup route. What time PE2 will wait until it can make sure that the main next hop or the main route is unavailable. If we issue command display OSPF pair, we can see the pair 10.0.0.1, which is the main route or the main next hop to network 10.0.5.5. And we have dead timer. The dead timer is 38 seconds. The total dead timer is 40. But according to issuing this command, it was 38. This dead timer reset to 40 when it receives a hello packet from the peer 10.0.0.1. So if there was no hello messages from the peer due to any failure with the peer, PE2 will have to wait 40 seconds until it can use the second or the backup route. This time could not be accepted. It's long time to switch or to restore. It's long time to switch or to restore the service to the backup route. We can issue this command again. At this time it's 33 seconds. Here it's changing. Here it's 32 and here it's 38 again. So it's changing. In order to make PE2 to detect that there is a failure with a peer quickly, we have to use BFD and we have to configure BFD to inform the OSPF protocol on the router that there is a failure. To do that, we have to enable BFD on the OSPF routers. As in the task, we have to configure BFD for OSPF routers in area 0. So in the topology, we have to configure BFD for PE1, for PE2, for P1, for P2. And we have to configure BFD for OSPF for the 4 routers in area 0. Back to the script, we have to configure BFD on the system view of the router, BFD, and we quit from the BFD view, and we have to go to the OSPF process, OSPF 1. OSPF process 1 is added for all the routers, and we have to configure BFD all interfaces enable under OSPF. And on each interface enabled with OSPF, and we have to add these two comments, OSPF BFD enable, and we have to configure the timers for BFD. In the task, we have to set the minimum interval for BFD packets to be sent and received to be 500 milliseconds, and the local detection multiplier to be 3, which means 500 multiplied by 3, 1500 milliseconds. The router has to wait for 1500 in order to declare that there is a failure, which is quite better than 40 seconds. So to configure the timer under each interface, we add command OSPF BFD and minimum TX interval 500, minimum RX interval 500, and detect multiplier 3. So let's copy the script. I'll copy the BFD section and the OSPF section. I'll copy this prepared script and paste it into all OSPF routers in area 0. In PE1, system view immediately and paste. I'll quit here and do the same on PE2 and on P1, system view immediately, do same, and on P2 system view immediately, and do same. Now I have configured PE1, PE2, P1 and P2 with the global configuration for BFD and for the OSPF process. Now I'll go to each interface and enable BFD for OSPF and set the required BFD timers on each OSPF interface. For PE2 I'll configure Ethernet 100 and Ethernet 101, and PE1 same, Ethernet 100 and Ethernet 101, and P1 same and P2 same. I'll configure PE2 on this video, and I'll configure offline the other 3 routers. The other 3 routers have same configuration as PE2. I'll copy the configuration for the interfaces and paste on PE2 system view. I have here error appeared on detect multiplier. I'll double check on this, and I'll configure OSPF BFD minimum TX interval 500, minimum RX interval question mark 500, and detect multiplier 3. I forgot to add 500 after minimum RX interval, and I'll do same for Ethernet 100. Don't forget to save your configuration, and I'll do same offline for PE1, P1 and P2. Before doing that, I have to update my script to have 500 after minimum RX interval. This is for PE1, and we have no errors here. Save the configuration, and I'll make same script for P1 and P2 offline. We have to verify that the BFD sessions for OSPF is working using command display OSPF BFD session all. I'll copy display OSPF BFD session all command and check on PE2. Now I can see that there are 2 BFD sessions. The BFD session state is up for the first peer over interface Ethernet 100. The local IP address is 10.0.0.2. The neighbor ID is 10.0.1.1, the loopback address, and the remote IP address of the peer is 10.0.0.1, and we have RX interval 500, TX interval 500, and the local multiplier is 3. And we have another BFD session in the up state with the other peer through interface Ethernet 101, and the local IP address is 10.0.0.9, neighbor ID is 10.0.6.6, remote IP address is 10.0.0.10, and RX interval 500, TX interval 500, and multiplier is 3.